Hello, I'm Hao Wang, the first year PhD student in the Department of the Industrial Engineering. Today, I will present our project of exploring the revenues of the university parking lot. The motivation of our project is the smart parking system. It's about allocating parking space and fundamentally reshaping space and the plan of the mobility. This advent of the smart parking system lead a crucial evaluation of the traditional parking models and the forecast of the parking revenue in, as some research did. But we found that there is a crucial gap existing in comprehending the potential impact of the uh, parking parking system, and our studies set out with two objectives. First, we aim to forecast parking for revenue utilizing predictive analysis. By leveraging data analysis techniques, we seek to develop a robust model to forecast the daily revenue. Secondly, our study tried to evaluate the impact of the sparking parking system on the parking revenue. By conducting a comprehensive analysis, we intend to elucidate the effect of the sparking parking system. So we got data from the Honk Mobile and the Poco Mobile applications, covering data from the September 2020 to December of 2023. We identified two specific parking locations, Casey Hall and Netherman Curve, referred as Zone A and Zone B. So from the table, we can see from Zone A, Zone B, we have the 1,186 daily revenue and the rest of the basic statistics. So in our methodology, we divide the model into two parts. First is model design, and secondly is the result analysis. In the model design, after literature review and finding gap collection data, we design an artificial neural network model to analyze the trend of the data. And after that in result analysis, we did the model performance evaluation. If the model is good enough, we implement model in the test sets and did the revenue result analysis, make a discussion and a conclusion. So in the model performance evaluation, we separate data into three subsets: training, validation, and test. We aim to assess the impact of the smart parking system because the smart parking system is implemented after September 2023. Before this data, we set as the training data and the validation data. So in the figure 2, we can see the blue line is the actual daily revenue. The green line is predicted daily revenue on train set, and the orange line is the predict daily revenue on the validation set. We got 0.89 R squared in the train set and 0.64 R squared in the validation set, which means a majority of the variance is explained by this model. So after that, we did the post-implementation revenue analysis. We implement model on the test set. So in the figure 3, left side, we can see the blue line is daily revenue after the September 2023, and the red line is predicted revenue after the September 2023. So because the introduce of the parking revenue, we expect it will increase the parking revenue. So the actual daily revenue should be greater than the predicted revenue. For easy to look, we aggregate every 7 days daily revenue as a weekly revenue. So we got in the right side of the figure 3, the weekly revenue after September 2023. So we can see the blue line is in above of the red line, which means that the smart parking system can increase the parking revenue in Zone A and Zone B. So after that, we conduct the paired t-test with one-tiered approach to the result. So we conduct 30 times in each of the model. In figure 4, we can see that the most significance is less than 0.5. So we reject our null hypothesis that exists no significant difference between the actual daily revenue and the predicted revenue. So in our conclusion, the predict model can predict the daily revenues successfully, and then the smart packing system can indeed increase the daily revenue.